Refining consists of purifying an impure material, in this case a metal. It is to be distinguished from other processes such as smelting and calcining in that those two involve a chemical change to the raw material, whereas in refining, the final material is usually identical chemically to the original one, only it is purer. The processes used are of many types, including pyrometallurgical and hydrometallurgical techniques. Lead equals cupellation equals. One ancient process for extracting the silver from lead was cupellation. Lead was melted in a bone ash test or cupel and air blown across the surface. This oxidized the lead to litharge, leaving a button of silver. In ancient times, the litharge was discarded, but more usually it was re-smelted to lead. Pigs of Roman lead have been found marked XARG. This presumably indicated that the lead had already been desilvered. This process was viable economically if the lead contained at least 8 troy ounces of silver per ton of lead. In the 18th century, the process was carried on using a kind of reverberatory furnace, but differing from the usual kind in that air was blown over the surface of the molten lead from bellows or blowing cylinders. Pattinson Process equals. The Pattinson process was patented by its inventor, Hugh Lee Pattinson, in 1833. It depended on well-known material properties. Essentially that lead and silver melt at different temperatures. The equipment consisted of a row of about 8 to 9 iron pots, which could be heated from below. Argentiferous lead was charged to the central pot and melted. This was then allowed to cool. As the lead solidified, it was skimmed off and moved to the next pot in one direction, and the remaining metal was then transferred to the next pot in the opposite direction. The process was repeated in the pots successively, and resulted in lead accumulating in the pot at one end and silver in that at the other. The process was economic for lead containing at least 250 grams of silver per ton. Parkes process equals. The Parkes process, patented in 1850, uses zinc to form a material which the silver enters. This floats on the lead and can be skimmed off. The silver is then recovered by volatilizing the zinc. Copper equals fire refining equals. The initial product of copper smelting was impure black copper, which was then repeatedly melted to purify it, alternately oxidizing and reducing it. In one of the melting stages, lead was added. Gold and silver preferentially dissolved in this, thus providing a means of recovering these precious metals. To produce pure copper suitable for making copper plates or hollowware, further melting processes were undertaken, using charcoal as fuel. The repeated application of such fire refining processes was capable of producing copper that was 99.25% pure. Electrolytic refining equals. The purest copper is obtained by an electrolytic process, undertaken using a slab of impure copper as the anode and a thin sheet of pure copper as the cathode. The electrolyte is an acidic solution of copper sulfate. By passing electricity through the cell, copper is dissolved from the anode and deposited on the cathode. However, impurities either remain in solution or collect as an insoluble sludge. This process only became possible following the invention of the dynamo. It was first used in South Wales in 1869. Iron wrought iron equals. The product of the blast furnace is pig iron, which contains 4 to 5% carbon and usually some silicon. To produce a forgeable product a further process was needed, usually described as finning, rather than refining. From the 16th century, this was undertaken in a finery forge. At the end of the 18th century, this began to be replaced by puddling, which was in turn gradually superseded by the production of mild steel by the Bessemer process. Refined iron equals. The term refining is used in a narrower context. Henry Court's original puddling process only worked where the raw material was white cast iron, rather than the grey pig iron that was the usual raw material for finery forges. To use grey pig iron, a preliminary refining process was necessary to remove silicon. The pig iron was melted in a running-out furnace and then run out into a trough. This process oxidized the silicon to form a slag, which floated on the iron and was removed by lowering a dam at the end of the trough. The product of this process was a white metal, known as finer's metal and refined iron. Precious metals, Precious metal refining is the separation of precious metals from noble metalliferous materials. Examples of these materials include used catalysts, electronic assemblies, ores or metal alloys. Process equals, in order to isolate noble metalliferous materials, pyrolysis and/or hydrolysis procedures are used. In pyrolysis, the noble metalliferous products are released from the other materials by solidifying in a melt to become cinder and then poured off or oxidized. In hydrolysis, the noble metalliferous products are dissolved either in aqua regia or in hydrochloric acid and chlorine gas in solution. Subsequently, certain metals can be precipitated or reduced directly with a salt, gas, organic, and/or nitrohydrate connection. Afterwards, they go through cleaning stages or are recrystallized. The precious metals are separated from the metal salt by calcination. The noble metalliferous materials are hydrolyzed first and thermally prepared thereafter. The processes are better yielding when using catalysts that may sometimes contain precious metals themselves. When using catalysts, the recycling product is removed in each case and driven several times through the cycle. Bibliography: J. Day and R. F. Tylcoat, The Industrial Revolution in Metals. Zar Paragraph Derberg, A. 2011. Evine Skaldespilus Silver, Refining and Standards in Pre-Monetary Economies in the Light of Finds from Sigtuna and Gotland. Secundary 2011. Edberg, A. Weekstra Paragraph M. A Sigtuna, R. F. Tylcoat, A History of Metallurgy. Newcastle University, Hugh Lee Pattinson. References